All right, so today we're working on Chapter 7, Lesson 3, using elimination with addition and subtraction. So what we're going to learn today is how to solve systems of equations by using elimination with addition, and by solving systems of equations by using elimination by subtraction, or with subtraction. So some of the vocabulary to keep in mind is, what is elimination? How can you use a system of equations to solve problems about weather? So on the winter solstice, there are fewer hours of daylight in the northern hemisphere than any other day. On that day in Seward, Alaska, the difference between the number of hours of darkness N and the number of hours of daylight D is 12. The following system of equations represents the situation. So here you go. The number of night hours plus the number of day hours should equal 24 because there's 24 hours in a day. And the difference of the hours of night and the hours of day is 12. So these are my two equations, my system of equations for this problem, right? Notice when we have them stacked on top of each other like that, the variable d would be eliminated if I were to add these together, right? So if I were to add these two equations together, n plus n is 2n, and 1d minus 1d, it would be 0. And 24 plus 12 is 36. So I'd be left with an equation of 2n equals 36. These two d's would eliminate each other. And that's what we're going to be working on today, how to use this strategy to solve systems of equations. So elimination using addition. All right. Sometimes adding two equations together will eliminate one variable. Using this step to solve an equation of systems is called elimination. So last lesson we learned about substitution. Today we're learning about elimination. So let's look at a problem. So example 1 here wants us to use elimination by using addition. In order to use elimination to solve each equation, system of equations. So I have 3x minus 5y equals negative 16, and 2x plus 5y equals 31. Again, they're stacked on top of each other. So when you are going to use elimination, you need to make sure that the x terms line up, the y terms line up, the equal signs line up, and then the constant, just the numbers with no variables line up, right? When everything's lined up, you can use elimination. That's a strategy anyways. And it's really similar to elementary school when we used to line up like 2 or 3 digit numbers and like you would line up the hundreds place and the tens place and the ones place in order to be able to use that method. So let's go ahead and do this. If I notice, look at the variables. Which variable do you think will eliminate, right? Will the x variable eliminate or will the y variable eliminate? I think the y variable will eliminate because if you notice, I have minus 5y and plus 5y. When I add those together, I know those will give me 0. So let's go ahead and do that. So when I stack the equations on top of each other, I know that 3x plus 2x is 5x. Negative 5y plus positive 5y makes 0, which is good because they eliminated. That was what I wanted to happen. Negative 16 plus 31 is 15. So now I have an equation of 5x equals 15. Notice how now I have an equation with just one variable, so I can find out what x equals now. I'm going to go ahead and divide both sides by 5. When I divide both sides by 5, I know x will equal 3. So now I found the variable x. I found that value. Well, remember, this is a systems of equation, right? A system of equation requires an x value and a y value. So since I found my x value, now I need to find my y value. So let's go ahead and let's examine the problem now. Knowing that we have the x value, all we have to do is substitute x in, right? The 3 in for x in either equation. It doesn't matter which one. It's whichever one you think is easier, right? I'm going to go ahead and substitute it in the first one. So 3 times x minus 5y equals negative 16. So remember the x we know is 3, so I'm going to go ahead and substitute that in. I know 3 times 3 is 9, and then now I just get to solve for the y. So I'm going to go ahead and subtract 9 from each side, and that's going to give me negative 5y equals negative 25. Divide both sides by negative 5, and I get y equals positive 5. So now I know my x value and my y value. So that would tell me that the solution occurs at the coordinate 3, 5, right? The x coordinate and the y coordinate. So this is a really similar strategy to substitution, except the first step is to stack them on top of each other in order to eliminate one of the variables. So let's go ahead and look at a second example. So here we're asked to write and solve a system of equations, right? So it says twice one number added to another number is 18. 4 times the first number minus the other number is 12. Find the numbers. So if we let x represent the first number and y represent the second number, we can start to write equations. So the first sentence says twice one number added to another number is 18. So twice the first number, so 2 times x, added, right, plus sign, to another number, y, which is the second number, is 18, so equal to 18. Let's look at the second sentence. The second sentence says 4 times the first number minus the other number is 12. So 4 times the first number, x, minus the other number, y, is equals 12. So now I have my two equations. Now I have a system of equations. So let's use elimination to solve this. So here are my two equations stacked on top of each other. If I look at the x variable and the y variable, I can see which one's probably going to eliminate. It looks like the y variable will eliminate. These terms will eliminate because I have positive y plus negative y, right? So when I add them, 2x plus 4x is 6x. Positive 1y plus negative 1y is 0. And 18 plus 12 is 30. So make sure that you pay attention to your signs there. So 6x equals 30, divide both sides by 6, and I get x equals 5. So again, I found the x value. Now I need to make sure I find the y value. So let's go ahead and take this, and we're going to substitute it now in either one of the equations. It doesn't matter which one. I'm going to go ahead and take that second equation I had. So I'm going to substitute 5 in for x. So it's going to be 4 times 5 minus y equals 12. I know 4 times 5 is 20. Again, I'm solving for the y, so I got to subtract 20 from each side. Leaves me with negative y equals negative 8. And then I go ahead and divide both sides by negative 1. Remember, you can multiply or divide both sides by negative 1. It does the same thing, because remember, I'm not solving for negative y. I want positive y. So that gives me y equals positive 8. So that means the first number was 5 and the second number was 8. So those are my two numbers that work for this problem. So elimination using subtraction. So we've used addition in both of the problems that we've done, but you can also use subtraction. You want to use whatever makes the most amount of sense that's going to eliminate your two variables. So sometimes subtracting one equation from another will eliminate one of the variables. So let's look at this problem. So elimination using subtraction. So using elimination to solve this system, I have 5s plus 2t equals 6 and 9s plus 2t equals 22. Again, if I look as they're stacked on top of each other, which term will eliminate? Will the s terms eliminate each other, or will the t terms eliminate each other? Well, I can see the t terms will eliminate each other because they have the same coefficient, right? 2 and 2 will eliminate, but if I add them, 2 plus 2 gives me 4, and I don't want it to give me 4. I want it to give me 0. And so this is an instance where subtraction is going to make more sense, right? Because I know 2 minus 2 gives me 0. So I'm going to have to subtract the two equations from each other, okay? So let's go ahead and do that. So instead of adding, I'm subtracting. So I have to subtract all these bottom ones from the top ones. So it's going to be 5s minus 9s. It's going to be 2t minus 2t. It's going to be 6 minus 22. So when I do that, 5s minus 9s is negative 4s. 2t minus 2t makes 0, which is what I wanted. They eliminated each other. And 6 minus 22 gives me negative 16. So now I have negative 4s equals negative 16. So then I can solve for s now, divide both sides by negative 4, and that's going to give me s equals 4. So now I know the s value. Now I need to go ahead and find the t value. Same thing, I'm going to go ahead and take the value that I know for s, substitute it in for the s in one of the equations. It doesn't matter which one you pick. I'm going to pick the top one just because it looks a little easier. It's got smaller numbers. So I'm going to substitute 4 in for s. 5 times 4 is 20. Subtract 20 from each side, and I get 2t equals negative 14. Divide both sides by 2, and I get t equals negative 7. So I have my S value and I have my T value. Remember, this is a coordinate. So it's got, typically it's X and Y, but here it's going to be S and T. Remember, it's always just in alphabetical order. So here I know the solution is 4, -7. So that's how you use elimination to solve systems of equation. Let me know if you guys have any questions, and please, thank you for watching.